Hello everyone, this is Britt Kongsted, and this is a video made for my PhD study, week 7 in research methodology. And today we are going to talk about quantitative analytics and the tool used and how we actually can use the tools in order to make some kind of statistics on the performance. So the thing is that I was provided by a set uh, of data provided by our professor, and the data set contains detailed information on sales, customer segments, product categories, and shipping behavior. The objective of my analysis is to understand how sales performance and profitability differ across product categories. The chosen problem statement focus on identifying which categories and subcategories generate the highest profit and which one contribute to financial losses. The data collection approach, the data set was provided in both CSV and SAV format as a structured retail data set. It has always been cleaned for duplicates and missing value, so I didn't need to spend time on that. It was containing more than required 100 records and included both numerical and categorical variables. This make it fully suitable for descriptive quantitative analytics. To answer the problem statement, I selected SPSS, which is well suited for descriptive statistics and group comparison. The main method I applied was descriptive statistical analysis supported by bar chart and category-based aggregation. The method fits the objective because I need to compare profitability levels across categories, not predict future values. The variables selected for the analysis include category, subcategory, sales profit, and quantity. Using SPSS allowed me to quickly group the data, calculate the totals and averages, and visualize this result clearly. However, I have to say that I prefer Excel, so of course you can combine the tools, so I did that for the graphics. So I just want to show you how I did it in PSPP. And the thing is that I start, of course, to open my data files. And I got a data set from our professor. So I will just import them and open them here. So as you can see, there is two sets of data, which is in the data view and also in the variable view. So the data view is basically just the raw data, and the variable view is a kind of setting up the in content of the data. I will not go into details here, but in reality, it is important to just look into if the data look real, and if there's some data which is not filled in, there's probably a kind of structural thing going on. But these data are cleaned already, so I don't need to do anything. The thing is that my purpose with this assignment is basically to look into profitability by category. And how I do that is quite easy. The thing is that I go to analyze, and then I go to descriptive. Let's see, now compare means and means. And then I will put in the numbers which I feel is a dependent list, and the dependent list is basically what I said. The sales is important, the quantity is important, and the profit. And then I take the categories here and put it in, and then I will get an output file which will show me the overview of the numbers. So what I can read here is basically that the category with the highest profit is technology, and after that it comes with office supplies, and then furnitures. And it gives me the totals, and I got and the mean and the standard deviations. So I want to display here. Let's say I want to have a bar chart about profit by category. And so I take profit, and I want profit cluster. That's up here, and then the category. Let's see. What is it? Yeah. Here it comes. Here you see the main results of the analysis. First, I created the descriptive table summarizing total sales, total profit, and average profit across each product category. Second, the bar chart highlight that the technology is the most profitable category overall. Office supply delivers steady, moderate profit, while furniture shows significant lower profitability, and in some subcategories even negative profit. This visualization makes the difference between categories very clear and support an initial business interpretation. In terms of interpretation, the results show that technology items drive strong profitability, likely due to higher margin or higher customer demand. Office supplies perform well, but at a lower margin, which is accepted due to a lower product price. Furniture stands out as the weakest category, with some subcategories such as the table generating losses. From a business perspective, this means that profit optimization efforts should prioritize reviewing pricing, discount strategy, or supply arrangement in the furniture category. It is also worth noting the limitation of the dataset. For example, it does not include the full cost structure, seasonal effects, or inventory-related factors. So my conclusion, we can conclude that the selected method and tool were highly efficient in answering the problem statement. The descriptive statistical approach allowed me to clearly identify which product categories perform strongest and weakest in terms of profitability. So SPSS support this process by providing structural tables and visualization that highlighted the key performances. However, I think Excel do a better job in the visualization, so it was exported to Excel. Overall, the analytics demonstrates how relatively simple quantitative tools can support data-driven decision-making in retail environment. Future work could include examining discount effects, performing regression analytics, so profitable drivers or analysis could be time-based on also trends. So this was my first time I was using PSPP, and I think it was a relatively easy tool to use, but also I think it was visually a little bit short, which I think is the purpose with these kind of assignments, to use both core tools but also supporting tools. So thank you for listening in, and thank you again. Bye.